Hey, welcome back, folks. This is Mrs. Sid. I promised you a video to finish up these notes because if you've looked at the homework, you're probably thinking, what the heck? We didn't do any problems like that. So this was page 2 of our notes, or kind of the start of our notes, since page 1 was a warm-up. So just a little reminder, we were looking at a parabola with 3 important features: the vertex, the focus, and the directrix. Feels a little weird because for years and years and years, we didn't know about the focus or the directrix. They were kind of behind the scenes. So in class, we went through problem 2A and 2B. And they're kind of nice problems to start with because the vertex is at the origin. So to start with a 0, 0 vertex gives you a good idea of how to work with some of the other stuff like the focus and the directrix. So let's switch the vertex to someplace more interesting. So now in number 3, you see how we have some quantities there. One is squared, one is not. But that means our vertex is not at the origin. So let's record some stuff over to the side here. So we're going to be looking for vertex, we're going to be looking for focus, and we're going to be looking for directrix. So let's start with the vertex. This is in a vertex form for us. I can read the vertex from what I've underlined in purple. The vertex is 3, negative 4. So just like the circle, I'm taking the opposite values. Now, I'm going to go plot 3 and negative 4 on my graph, just so I can start to visualize what's going on here. So 3 over 4 down. So there's our vertex. And now y is squared. That's kind of a weird deal, right? We're used to having x squared. You did a bunch of x squareds when you were in Algebra 1. So that tells me that this is going to be opening either right or left. So how do I decide? I look at this number here, and I see that it's positive. So this parabola is going to be opening to the right. So if I wanted to sketch it, it's going to be something like that. And sometimes sketching it gives you an idea of just where things are going to be. So the next piece I'm going to do is figure out what that p value is. So that's where we go to the 20 and we rewrite it as 4 times a number, in this case 4 times 5. So that 5 is my p value. Well, what does that mean? That means the focus is 5 units away. And remember, it's always inside the parabola. So 1, 2, 3, 4, 5. And then the directrix is going to be 5 units behind. 1, 2, 3, 4, 5. And I'm going to draw in my directrix. So now that I have them drawn on my graph, I'm going to record them off to the side. So my focus is 8, negative 4. And my directrix is x equals negative 2. Remember, that's a line, so it's got to be an equation of either a vertical or a horizontal line. Now, I'm going to erase that gray sketch that I had, and I'm going to go ahead and sketch my parabola. A p-value of 5 is kind of on the larger side, so this is probably somewhat wide. I wouldn't say very wide, but somewhat. If it feels like you're sketching and just sort of eyeballing it, you're right. You are. Remember, what we're trying to really get at is the distance from, so any given point on this parabola, this distance and this distance should be the same. So obviously I didn't do a great job because those distances don't look quite the same, but they should be. That's really what we're going for there. Okay. So let's move on to one that's not in vertex form, because that's where your homework starts. Oh, right, in standard form. So your homework is stuff like down here in part A. Let's take a look at this. This is interesting. It gives us the focus and the vertex, and we're going to come up with that standard form or vertex form. So let's take a look and see what we have. I'm going to head to my graph first. I think it helps me just to visualize. So vertex is -1, 2, and focus is 2, 2. So it's looking something like that. Okay, so what information does that tell me? Well, if I'm thinking about what form to use, I can see that this opens to the right. So I'm thinking of the form where it's y minus k squared equals 4p times x minus h. So I can fill in my h and k. So this is going to be y minus 2 squared equals 4 times some number times x plus 1. So the p-value is staring at us on the graph. This is our p-value. So let me count how long that is. 1, 2, 3. So this tells me that my p-value is 3. So that means my equation is y minus 2 quantity squared equals 12 times x plus 1. Now, when I think about it, this is standard form. I'm just going to keep it in this vertex form. I'm not sure I'm really worried at this point about us going to a standard form. If you're like, wait, but what is standard form? It's, for your homework and for our work right now, that's just not important. I'd much rather focus on vertex form. So I'm pretty happy with that as an answer. Okay, so let's take a look at these two, because these are definitely just like stuff you're going to see in the homework. Let's get a fun color here. Let's do like a fun green. Okay, so when I'm looking at that part A, what I see is that my parabola equation is all jumbled up. So I'm going to have to do some completing the square. And when I do the completing the square, whatever variable is squared, I want to keep that variable and all the terms that carry it on one side and everything else on the other side. So what do I mean by that? Well, I'm going to move the 9 over, so I'm going to have 8y plus 9 equals, the x squared and the 2x are going to stay on the same side. Now the reason I've created a blank, or kind of a space there, is because I want to complete the square. So remember, to complete the square, I look at this number, divide by 2, and then what goes on the blank is going to be -1 times -1. So in this case, that's a +1. So, oh, I made a mistake. I don't know if you saw that, folks. This should not be a +9. I moved it over. It should be -9. All right. Chalk that up to a Friday afternoon mistake. All right, let's keep going. At least I caught it before we did anything else. So that means this right side is going to be x minus 1 quantity squared. We completed the square so that we could write that as a squared quantity. This left side is going to be 8y minus 8. That's quite lovely. I'm going to take an 8 out. And the reason I said that's quite lovely is because 8, first of all, was a number I could factor from both terms. And 8 is divisible by 4. So if I really wanted to break down, by the way, this would be a vertex form. If you want to take a look at that. But if I want to break it down so that I can see my p-value, I can write that as 4 times 2. And now let's take a look at writing some stuff down. So vertex, x coordinate is 1, y coordinate is 1. So let's plot that. And then that p-value being 2. Oh, wait, let me back up. I need to know if it opens up, down, left, or right. So x is squared. So that means this is going to open either up or down. And my p-value is a positive 2, so it'll open up. So I'm kind of thinking it's going to look something like this. All right, so now back to that p-value. So 2 means that if I'm starting at my vertex, I go 2 up to draw the focus. I go 2 down to draw the directrix. Now, 2 is a pretty small number, so if I really do want to graph this, which it says graph each one by hand, 2 means it's going to look like a tighter U. It's not going to be as wide. So I'm going to draw it much like one of the parabolas I would have seen freshman year. And now I'm going to head back and make sure I have everything filled in. Well, the focus is the point 1, 3. And the directrix is y equals -1. If you're like, wait a minute, how did I use that p-value again? Remember, this distance here is p, and this distance here is p. All right, let me do another one just like that, because the more examples always help. All right, so for this one, same idea. Whatever variable is squared, I want to keep that variable on one side and everything else to the other side. So this is x squared minus 6x. I'm going to put plus blank, and I'm going to move that 4y over, this time remembering to subtract it. And then I have to figure out what goes in the blank. So -6 divided by 2 is -3. So in my blank is -3 times -3. By the way, I kind of know I'm on the right path because I'm just sort of looking. 11 plus 9 is 20, and 20 is divisible by 4. So I can factor that 4 out. So life is going to be good. So this left side is x minus 3 quantity squared. This right side is -4y plus 20. But again, I want to factor out that -4. I basically want the coefficient of this y to be 1. So I'm taking out the -4. So if that were a +4, I would have just factored out a +4. If that was a +10, I would have factored out a +10. So whatever number is in front of the y, I'm just taking that out. Okay, so I'm in vertex form now. You can see it. And so my vertex is 3, 5. So let me plot that. So I'm going to go 3 over and 5 up. And then I'm going to look at this and write it as +4 times -1. Okay, so that p-value is negative. So let's think about this. Is this an up-down or a left-right parabola? X is squared. That was normal freshman year. So this is going to be an up-down parabola. But the fact that our p-value is negative, it's going to be a down parabola. So it's probably going to look something like that. Again, I put the sketch in just to visualize what's going to happen. So the p-value being a -1, we've taken care of the negative because it opens down. But now the 1 part. So focus is inside, directrix is back behind. So I look at the graph, that's the point 3, 4. There's my focus. And directrix, since it's a horizontal line, is going to be y equals 6. Now I'm going to erase that sketch and draw it a little bit nicer. So 1 is pretty much the smallest p-value we've seen. So I'm going to draw this a lot like my parabolas from freshman year, nice and tight and skinny. And I think I'm good with that graph. So doing these last two problems, if you want to pause this video now, you could do problems 1A and 1B and 1C on your homework. They're very much like this. The only difference I would say is 1A is going to be opening either left or right, and then same thing with 1C. It's either left or right. So if you want to pause, go ahead and pause and work on those problems and come back. And now let me do the last problems on your note sheet here, so that again, you just have some more stuff to work with. So these are a little bit harder just because they only give us a limited amount of information. So let's take a look at what they have and we'll kind of sort of piece together what we have and what we need. So we know that the parabola contains the point 3, -1. Okay, so that does not help me at all. I could still open up, down, left, right. I have no idea what's going on. So let's move on to the next one. It says symmetric to the y-axis. Well, what does that mean? Well, symmetric, think of that as that axis of symmetry. So this actually tells me something. This tells me if it's going to be symmetric to the y-axis, I can fold along the y-axis and get the same shape on either side. So this tells me that I'm either going to be opening up or down. Let's look at this last piece and see if it'll help us. Vertex at the origin. Oh, that's awesome. Okay, so vertex is here. I'm definitely not opening up because then that won't allow my parabola to go through the point 3, -1. So this must open down. So if this is a point on the parabola, -3, -1 is probably a point on the parabola too. All right, so I have my sketch there. And this is super nice, this vertex at the origin, having 0, 0. Oh, that's dreamy. So it opens down, that means x is squared. So I'm really looking at x squared equals 4py. It's kind of where I'm going to start. The reason I don't have an h or a k is because h and k are both 0. So it looks like the only thing we need to find is p. If we had our value of p, life would be good. So what can I do to find p? Well, I know this is an x, y coordinate that is on my parabola. So what I'm going to do next is I'm going to plug in 3, -1 and solve for p. So 3 squared equals 4p times -1. So 9 equals -4p. So it looks like p is -9/4. Now, you might be tempted to make that into a decimal. I actually would encourage you to not, because we are going to go ahead and take that p-value and plug it in here. So x squared equals 4 times -9/4 y. And these 4's are going to cancel out. So we get x squared equals -9y. That would be the equation of our parabola. Not pretty, but it works. All right, let's do another one like that where we have to sort of piece together what's going on. Okay, so actually I'm going to go to the last piece here. It says vertex at the origin. So this is another 0, 0, which is lovely. It means we don't have to worry about h and k. And it tells us it opens left. Beautiful. So it's going to look like that. Oh, and it gives us another point again. -3, 3 goes through my parabola. Okay, so if I'm sketching it, It's going to look something like this. Well, that's a terrible parabola, but you kind of get the idea. So let's put some pieces together. Because it opens left, that means I'm going to have y squared, right? It's going to be weird. So this is going to be y squared equals 4px. So I would be done, but I don't know what p is. So kind of like with the last one, I'm going to plug in that negative 3, 3. So plug in negative 3, 3 to solve for p. So I'm going to, let's see, this will be 3 squared equals 4p times negative 3. So 9 equals negative 12p. So if I divide by negative 12, that's what negative 3/4 is our p-value. I'm going to go back and plug that in up here so that I get my equation. And when I multiply negative 3/4 times 4, those 4's cancel. So I get y squared equals negative 3x. Not a fun equation to deal with, but it wasn't too bad given the information we had. So at this point, looking at homework questions 2 and 3, you should be able to do them. The vertices, or the vertex of each of those parabolas, are not at the origin, and they're kind of giving you some different information, but I think you're going to be able to do it if you use your graph. So if today or this video were totally confusing, please reach out. We can go over more stuff, practice more stuff. I would also highly recommend looking in chapter 9 in our textbook. They do a pretty decent job of showing more example problems and kind of talking you through what's going on. All right, folks, I hope you have a wonderful weekend, or maybe if you're watching this on Monday, I hope you've had a wonderful weekend and enjoyed the snow. I will be back with you on Wednesday, but feel free to reach out if you want help before then. Bye.